Hi everyone, so today we're going to look at the binomial PDF and binomial CDF functionality in your TI-84. So we use this for binomial distributions. When we say binomial distributions, there are actually three requirements. The first one is there must be a fixed number of trials. The second one is each trial is independent of the other. And the third one is there should only be two possibilities, a success and a failure. Okay, so let's take a look at this example. So I have a bag containing 6 pink and 5 blue marbles. Trisha was asked to pick one marble and then put it back in the bag. We want to find the probability that she picks a pink marble. Okay, so that is pretty straightforward. That will be 6 out of 11. Okay, so 7 others were asked to pick marbles, each time returning the marbles they have picked. Let X be the number of times that a pink marble was chosen by these 8 students. We want to state the distribution of X. Okay, so if we take a look at how X is defined, it's the number of times that a pink marble was chosen, which means that success could be getting a pink marble and failure is not getting a pink marble. 8 students have done this, which means that 8 could represent the number of trials that we're doing, and each student should be independent of the other, because each time one student gets a marble, it is returned. So this is what we call with replacement. Okay, so this is a perfect fit for a binomial distribution. So we're going to say that X is binomially distributed, and we will have two parameters when we describe a binomial distribution. The first parameter is the number of trials. The second parameter is the probability of success. So here we have tried 8 times, and the probability of success is 6 out of 11. Okay, so next we want to write down the probability that exactly 3 pink marbles were chosen. Okay, so notation wise, that is the probability that X is equal to 3. Okay, so we're going to use our calculator for that, and we go to second function, distribution, and we press the up button because the binomial PDF and CDF are closer to the bottom. So this is exactly 3, so we're going to use binomial PDF. Okay, so we're going to specify the number of trials, that's 8. The probability is going to be 6 out of 11, and the X value is going to be 3. Okay, so the X value is how many times exactly you want that number of successes to happen. Okay, so we get that answer, 17.6%. So in your working, writing P of X is equal to 3 is appropriate working, but additionally you might want to write what you have inputted in your calculator, just so that we could go back to it later if you want to check your answer. Okay, so that's 17.6% to 3 significant figures. Okay, so next question is, what's the probability that at most 5 pink marbles were chosen? Okay, so at most 5 means less than or equal to 5, not exceeding 5, but including 5. So we're going to write that as the probability that X is less than or equal to 5, and we use the cumulative distribution function for this one. Okay, so we go back to second var's distribution, go to binomial CDF. So binomial CDF is a function that accumulates all the probabilities from X equals 0 all the way up to the X value that you specify over here. So we have 8 trials, we have the probability of success is 6, and I want an accumulation of values from 0 all the way up to 5 because I want the probability from x less than or equal to 5. Okay, so I'm just going to write the calculator notation that I have used. 8, 6 out of 11, 5, and we write that as 0.788 to 3 significant figures. Okay, and our last example is what's the probability that more than 4 pink marbles were chosen? So more than 4 is x greater than 4. The binomial CDF function is actually accumulating from 0, but we want only above 4, which means we want 5 and above. So what we need is 1 minus the probability that x is less than or equal to 4 because we do not want to include 4. Okay, so that's 1 minus, so I'll just write that in my calculator, 1 minus, I still use binomial CDF and remove everything from 0 to 4. Okay, so that's binomial CDF, 8, 6 out of 11, 4, and that's equivalent to 0.466 to 3 significant figures.